This video covers a concept called isotopes. And isotopes is something that I introduced very briefly in the last video when talking about one of the things that we know is not true about Dalton's atomic theory anymore. The definition of an isotope is that it has the same number of protons but different neutrons. So the same number of protons, it's an atom that has the same number of protons but a different number of neutrons. The first term I want to introduce you to, along with this idea of isotopes, is atomic number. There are a few confusing terms in this chapter. Atomic number is different than mass number, which is different than atomic mass. So again, atomic number is different than a term called mass number, which we'll talk about, which is different than another term called atomic mass. So let's go back to atomic number. Atomic number is abbreviated with a Z, and is just a fancy name for the number of protons in an atom. It typically can be found above the element on the periodic table, and it is always a whole number. So here's a blow-up of the element nitrogen. So if you look at the periodic table, you'll see that number 7 is nitrogen. And this number right here is the atomic number for nitrogen. So we say that nitrogen has an atomic number of 7. And what that means is that all nitrogen atoms have 7 protons in them. And as I said in the last video, the number of protons is the identity of the atom. So if you're an atom and you have 7 protons, there's no other element that can be other than nitrogen. Any atom that has 7 protons is going to be nitrogen. The next term I want to talk about is mass number. Mass number is also always a whole number, just like the atomic number. And what the definition of the mass number is it is the sum of the protons plus the neutrons in an atom. So it's the sum of the protons and the neutrons in an atom. And the abbreviation for mass number is actually A. And the reason it's called mass number is because the protons and the neutrons are the most massive subatomic particles in the atom. There are 3 different ways that you can communicate that something is an isotope. One way is to write the element symbol. Write the element symbol, we'll just call it generically X, and then put the mass number up in the upper left hand corner, the atomic number in the bottom left hand corner. Another way to do this is just have the atomic or the element symbol and put the mass number in the upper left hand corner without putting anything in the bottom left hand corner. And the third way to do it is write the element's name and then write dash and then whatever the mass number is. So let's take a look at these 3 different ways to write an element's isotope for a very common isotope called carbon-13. One way to do this is write 13 carbon-6. Another way to do it is just write 13 and then C for carbon. And the last way is to write out the word carbon-13. All of these are called carbon-13, and all of these mean the exact same thing. For all neutral atoms, which we're going to assume for right now that all atoms on the periodic table are neutral. Neutral essentially means that it has no charge. And so if an element has 7 protons, that's like having 7 plus charges. And so to have no charge, it must also have 7 electrons, which would be like having 7 negative charges. And you can see if you add up these 7 plus charges and 7 negative charges, you're going to end up with no charge. And that's why we're saying that all neutral atoms are going to have the same number of protons as they do electrons. So the protons and the electrons will be exactly the same. Okay, let's take a closer look at carbon-13. And let's do the P and E, which is the protons, neutrons, and electrons for carbon-13. If you look on the periodic table, you'll see that the atomic number for carbon is 6. So the number of protons that all carbon atoms has is 6. And remember that this mass number is the protons plus the neutrons, which means that carbon-13 must have 7 neutrons. And then what we just talked about being a neutral atom, the number of electrons must also be 6, because the number of protons and the number of electrons must be the same if it is a neutral atom. So 6 protons, 7 neutrons, and 6 electrons for carbon-13. The next term I want to talk about is average atomic mass. The average atomic mass of an atom or an element is just the weighted average of all of the naturally occurring isotopes. And I'll show you how you can actually calculate this out in a couple minutes. But average atomic mass will almost always be a decimal number. You can see the average atomic mass for nitrogen is 14.0067. Now let's look at the calculation for this. What you're going to do to calculate this out is you're going to take the percent of the isotope as a decimal, and then you're going to multiply that by the mass number of that isotope, and then you're going to add that to all of the naturally abundant isotopes. So again, the next isotope's percent along with its mass number, and you're going to keep on doing that and add these all together. And again, this should be a decimal number once you get done. And that's almost always going to be true about the average atomic mass. All periodic tables are slightly different, whether we use the one off the internet, one in your book, or one I give you. So in order for us all to be on the exact same page, I want you to round all of your atomic masses to 2 places after the decimal. For example, in your book it says hydrogen has an average atomic mass of 1.0079, and you're going to round this to 1.01. And on this last slide I showed you nitrogen had an atomic mass of 14.0067. So we would round this to, so that's at 14.0067. We're going to round that to 14.01. Again, we're always going to go out 2 places after the decimal for all average atomic masses. And that'll be the case all year long. That way, it doesn't matter which periodic table you use, you should end up with the exact same answers that I do in class. Alright, let's look at the average atomic mass calculation of chlorine. If you take chlorine from nature, what you'll see is that 75.77% of that chlorine is chlorine 35. About 24.23% of that chlorine sample will be chlorine 37. And so that we don't give more weight to something that doesn't deserve more weight, we do something called a weighted average. And like I showed you before, that's taking the percentage as a decimal, so that's 0.7577, and you want to multiply that by the mass number for that isotope, and add up all of the different isotopes that way. So it's 0.2423 times this isotope, which is chlorine 37, and then you're going to hit equals. And what you should end up with, for chlorine at least, based on these numbers I've given you, is an average atomic mass of 35.49. It doesn't match exactly with what's on the periodic table, and the reason is because I made up these percentages myself, and those are not the actual percentages of the isotopes of chlorine. So hopefully that doesn't confuse you. I believe that on the periodic table it says that chlorine is 35.45. So I came pretty close, you can see, but not exact. The next problem there is calculate the PNE, the protons, neutrons, and electrons for silver 108. So keep in mind that 108 is the mass number. We can figure out the number of protons by looking at the periodic table, and if you look up silver, you'll see that silver has 47 protons. It has an atomic number of 47. And in order to keep it a neutral atom, we're going to make sure and give silver 47 electrons. In order to figure out the neutrons, we're going to take the mass number and subtract out the protons. And you should get a number of neutrons of 61. So there's the PNE, the 47 protons, 47 electrons, and finally 61 neutrons. Okay, there's one more problem on your sheet to do, and that's the protons, electrons, and neutrons for chlorine 35. So chlorine 35 looks like this. And if you look up at the periodic table, you can see that chlorine has an atomic number of 17. So that's how many protons it has. And it has 17 electrons as a neutral species. And then remember, the protons plus the neutrons, these two things, have to equal that mass number. So the neutrons must be 18. So here's the PNE, the protons, neutrons, and electrons for the isotope chlorine 35.